Good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 101 is on the screen. Let's get started, please. This is a continuation of the warm-up from yesterday. See how you do with those. Let's get started, please. I'll give you guys some time. Copy and go. All right. So, warm-up 101. Here we go. Let me go over this ASAP just to make sure we got it. Here goes one more time. It says make an infinite table for f of x equals 1 over x and plot the points. So anytime they ask you to graph a function, we said to use which values, everyone? -2, -1, 0, 1, and 2. From there, I take my function 1 over x. So if I substitute -2 there, then that becomes -1/2. If I substitute -1 here, 1 over -1 is -1. 0, there's no such thing as 0 on the denominator. That's why we write undefined or UND. 1 goes there, so that's 1 over 1 is still 1. 2 goes there, and that is 1/2. To graph that, here we go, -2, we got 1, 2, 1, 2. This is -1. This is +1. So, -2, 1/2, or -1/2. -1, -1. And I said to make a little curve like so. On this side, we got 1, 1, and 2, 1/2. And again, another little curve like so. And once again, I'm giving you a soft intro. This is the next function we're going to be looking at, known as rational functions. Rational functions. All right, let's go to number 2. Graph f of x equals x cubed. Once again, by now we should be able to graph that without a table. Here it goes. 0, 0, 1, 1, 2, 8, -1, -1, -2, -8. There you go. And according to this transformation, what is the first thing we do with that? Tell your neighbor, please. What do we do with that? First thing. All right, Mariah, what do we do with that? Flip it. That is correct. So it flips. And then from there we move it 2 to the left and 5 down. 2 to the left, 1, 2. 5 down, 1, 2, 3, 4, 5. So then our new function is going to be somewhere down here. All right, let's go to number 3. Number 3 says factor. Well, first of all, for this one, is it in standard form? Yes. Is there a GCF? No, so we group 2 at a time. GCF for the first 2, that's 5x to the second. We're left with x plus 2. What's GCF for the second 2? That's -4. We're left with x plus 2. What's the same here and here? X plus 2. And what's left over? 5x squared minus 4. So far so good, yes? Number 3b. Is there a GCF? No. However, there is a number in the front, so I need to multiply that times that. So 12. 7 underneath. What 2 numbers multiply give me 12 when you add them give us 7? That's 3 and 4. However, we have this number in the front, so we put that on top of the 3 and on top of the 4. Question. Can I simplify the 2/3 anymore? No, so that's 2x plus 3. Can I simplify 2 over 4? Yes, that's 1/2. Is that correct? So it's 1x plus 2. All right. Number 4. Synthetic division. By now we are experts at this, yes? All right. Show your neighbor yours really quick. See what they did, just to make sure they got the process down, what they do for that one. Caitlin. Right? All right. Walk us through this process. Renzo, what is the first thing we check for? Is it in order, guys? Let's check. Third degree, second degree, 0 degree. Is it in order? Yes. However, is a degree missing? Yes. Which one? The 1. Box it because we need that place. This one, first degree, 0 degree. It is in order, so set it equal to 0. Solve. Plus 2 plus 2. We end up with x equals 2. So my divisor is 2. Now we write our coefficients. Now, some of y'all, this is one thing that I've noticed, are writing these numbers down. We don't write those numbers down. We write the coefficients of each term. What is the coefficient here? A 1. Second degree, what is the coefficient on the second degree? That's a 3. What is the coefficient of the first degree? There's no first degree, so I write a 0. And what is the number there for the 0 degree? That's 1. Bring down the 1. All right, multiply. 2 times 1 is 2. Combine, that's 5. 2 times 5 is 10. Combine, that's 10. 2 times 10 is 20. Combine, that's 21 as remainder. So now check this out. We started with a third degree, but once you do a division, you lose a degree for all the numbers. That means that this one's no longer x cubed. That one is x squared plus 5x plus 10. We have a remainder. You make a fraction and write your original divisor on the denominator. Hands, have you got that by yourself? Yeah, by now we're experts because we need that for today. Trying to get us going right now. And number 5, solve the quadratic equation. All right, here goes. First things first, set it equal to 0. 0 equals 3x squared minus 15x minus 42. Next, is it in standard form? Yes. Is there a GCF that divides all terms? Yes. 3. We're left with x squared minus 5x minus, is it 14? Yes. Equals to 0. Next, negative 14 and negative 5. What two numbers multiply give me negative 14? That when you add them, give us negative 5. Gabriel. 2 and negative 7. So my factors are x plus 2, x minus 7, and bring down the 3. From there, set each one equal to 0, 3 equal to 0, x plus 2 equal to 0, x minus 7 equal to 0. This is not true, so it eliminates. Minus 2, x equals negative 2, plus 7, x equals 7. These are my solutions. Let's see if you remember all the names. Solutions, roots, x-intercepts, also known as zeros. And you're going to see today in regards to zeros because that's where we're headed. Hands if you got that by yourself. Some of us, okay, not bad. Copy the agenda, please. Warm-up 101. Today we're moving on to factoring polynomial equations. No longer small polynomials. Now we're going into functions or equations. And tonight, totally 4 problems only. 4 problems only. Already? Because today is going to be the day. Let's go. All right, we good? All right, copy the code for access to the home plate, IPXJ5. IPXJ5. Gotcha now. So, as I was sharing with my other classes, is that, just giving you a heads up, from time to time, I'm going to be having you guys do some work here in class like we always do. Sometimes you get into pairs and such. But instead of picking up the home plate from the day before, I'm going to pick up your notes from the day before. Right? You guys are doing tic-tac-toe. I'm over here playing chess. Let's go! That's going to count as your 15% class participation. It's only a letter and a half of your grade, only. Anyways, with that said, last night's home plate, go to Canvas, turn that in, please. It's only 8 problems. 4 of them were synthetic division. 4 of them were factoring. Tonight's home plate, there it is. Now, once again, if your Nearpod code somehow does not work from this point forward for the last 4th quarter that we're going to have for the school year, just go to the YouTube channel, go to the video lesson. It should be in there. Tell your neighbor what I just said, please. Go to the YouTube channel. All right, good. All right. So turn that in. Get a Cornell note ready. I'll give you guys some time. Go. Getting funner by the minute. Let's go. Funner. Yes, that's my word. Go tell your language arts folks. I don't care. Oh, Franco, I was just remembering my first board was a original Santa Cruz board. It was a 1983 Santa Cruz. Really? Santa Cruz? Oh, nice. All right. So, 2 variable equations. Do we have equations with 2 different variables? Yes, Mr. Q. All right. However, look at the non-examples. Tell your neighbor why those are not polynomial equations. And then Joseph is going to enlighten us. Why are those not polynomial equations, Joseph? They're not equations. What do we call those? Joseph, my goodness, what do you have for breakfast? Let's go. Yeah, expressions. That is correct. So, hashtag, write those down. They have to be equations only for polynomial equations. They have to be 2 variable equations. And they're going to have various terms. Do you see stuff with various terms? Yes. So get used to seeing these because we're going to be getting into some of those a little bit more. Okay? Also, now that the fair is gone, I think the last day of wind was yesterday. It's going to start warming up already for the rest of the week. Next week, we're going to hit the 96 degrees. Let's go. Bring it. So start practicing doing this. When you get in the car, right? Ah. All right, here we go. Zeros and rationals. Write your utensils down, look up to the screen. So, Mr. Q, where are we headed with this? Well, I've been talking about zeros since last semester, kind of like left off for a little bit, but let me remind you what they are. Whenever we're talking about zeros from polynomial graphs or functions, look up. Zeros is where our function intersects the x-axis. Zeros is when a function intersects the x-axis. So how many zeros do you see there? 4, that is correct. 1, 2, 3, 4 zeros. Now, are we going to get to graph like this? Of course. this week. Let's go. All right, next, rational numbers. Let me give you a rational number, 23 microjoule. Why is that a rational, Mr. Q? Because we can write it as a fraction. How about 0.75? Yes? Can we write that as a fraction, Mr. Q? Yes, that's 3/4. So any number that can be written as a fraction is known as a what? Rational. Okay. So with that said, you're still paying attention, don't copy this. Today I'm going to introduce something called the rational zeros theorem. What does that mean, Mr. Q? That if I gave you a polynomial, we can use this theorem in order to find all the factors of the polynomial. Use this theorem to find what? All the what? Factors of the polynomial. All the what, Mario? Yes. Now, in long words, this is what it says. Pretty confusing. However, I'm going to put it to you like this. The rational zeros theorem is basically a fraction that you form from your polynomial. What do I use, Mr. Q? Well, the top is the LC, known as the, oh my bad, the other way around, sorry. The denominator is the LC, and the top is our constant of the polynomial. So for example, look up please. If I gave you a polynomial function that looked like this, f of x equals 5x to the 4th plus 3x to the 3rd minus 4x squared plus x minus 7. Are we there? Well, I need to make a fraction using the constant. What is the constant from there? And what is the leading coefficient, everyone? So our fraction would have been 7/5. Are we there so far? Okay, so write on your paper, rational zeros theorem, and then write this, and as an example, just write that on the side so that you can have that as a reference. I'll give you some time. Go. All right, we got it? Once again, you don't need all the words. We just need to copy this and this. All right, so with that said, example 1. It says, find the rational zeros of the polynomial function, then write the function as a product of factors. F of x equals x cubed plus 2x squared minus 19x minus 20. Copy the whole thing, please. Let it go. Let it go. There it is. Copy the instructions as well, please, so you can have at least one with the entire example in there in your notes. We're going to do this one together. All right, here we go. Example number 1. We are given f of x equals x cubed plus 2x squared minus 19x minus 20. So, step 1. In order for us to find all the rational zeros before we get there, I just want these factored for today. Are we there? So, how do I start, Mr. Q? Step 1. You make a fraction using the constant. What is my constant, everyone? -20. And what is the leading coefficient? 1. So do that. Write that down. Step 2. We're going to find all factors of those two numbers. And I want you to do this. I want you to put plus, minus, and I'll address that in a little bit. Put plus, minus, and I'm going to start with the numerator. 20. What two numbers multiply to give me 20? Well, 1 times 20. What else? 2 times 10. What else? 3 times nothing. What else? 4 times 5. And we're done with all the factors for 20. How about 1? 1 is just 1. Okay. Therefore, this is what we're going to be searching. Look up. We need plus minus 1, 2, 4, 5, 10, and 20. All right, so what is that, Mr. Q? Well, what this is, look up please. To start with, I'm going to be trying each of these numbers until I find one possible factor known as a 0. Okay? So how do we start, Mr. Q? Well, the process is using synthetic division. So here we go. To start off, I'm going to start with blue. I'm going to circle the plus 1. So I'm going to use that as my divisor. So write that there, please, if you have blue. So if that's my divisor, what do I write for my polynomial, guys? 1 for the invisible one, is that correct? What else? 2, what else? Negative 19, what else? Negative 20. Now let's double check. Is this in standard form? Let's see. 3, 2, 1, 0. Yeah, nothing's missing. Okay. All right, let's do the division. Bring down the 1. Here we go. What is 1 times 1? 1 combined, that's 3. What is 1 times 3? 3 combined, that's negative 16. What is 1 times negative 16? Negative 16, and that is negative 36. Guess what? Look up. Cross this one out and write not a 0. What does that mean, Mr. Q? That the remainder has to be a what? A 0. So now we practice or used positive 1. Where am I going next? Negative 1. So I'm going to write negative 1. Same values, 1, 2, negative 19, and negative 20. Bring down the 1. Here we go. What is negative 1 times 1? Negative 1. Combined, that is 1. What is negative 1 times 1? Negative 1, that's negative 20. What is negative 1 times negative 20? Positive 20, combined, that's 0. Well, guess what? This is our what? Our 0. Why is that our 0? Because we ended up with a 0 remainder. Okay, so writing utensils down, look up to the screen. This is very important, the next step. This is written in synthetic form. What was this before I wrote it in synthetic form? Think about last night's home plate. How would I write this with a variable not in synthetic form? Talk it over your neighbor. How would I write that? With a variable not in synthetic form. All right, looks like Caitlin's got it. Very good, Caitlin. Ashlyn's got it. I see you, Ashlyn. Sean. Mariah's got it. I see. Let's go with Yulisa. Yulisa, if this is negative 1, and think about yesterday, the work that we did, what did we do on the side to get that number? How would we write it before it became that? Subtracting from each, right? So therefore, instead of being negative 1, now it's what? X plus 1. Is that correct? Write that down, please. Because if I put this equal to 0, doesn't that give me negative 1? Yes. So my first 0 is that. Are we there so far? Okay. Next. What do we have left, Mr. Q? Well, let's see. We started with a what degree? Third. That means this one becomes what? X squared. How about that? X and then minus 20. Are we there so far? Next, does your brain want to do something with this in order to factor? Tell your neighbor what your brain wants to do with that to factor that. Very good. Negative 20. And this is a 1. Tell your neighbor what two factors give you negative 20 when you add them give us positive 1. Factors are, Caesar? Negative 4 and 5. So this turns into x minus 4, x plus 5. Are we there? So we're pretty much done. Check this out. Now I just need to rewrite this in factored form. Here it goes. I start with what? F of x equals, what do I have here? X plus 1 times x minus 4 times x plus 5. So, let's look at the process one more time. What did I do first, Mr. Q? Well, started off with a constant divided by the leading coefficient. From there, you factor each number. So this one is all factored. 1 is 1. Then we just divide each of those numbers. We write them again, plus, minus, and I start trying now with synthetic division, starting with plus 1, those numbers, till I find my 0, and then the rest we factor whichever way we can. All right, from 1 to 5, I'm comfortable with this so far? Yeah, 4, 5, 4, 5. Let's do another one. Copy this one. Example 1Q. Don't copy the instructions, just write g of x equals, oh my goodness, fly. G of x equals x cubed plus 7x squared plus 16x plus 12. I'll give you a head start. Go. All right, here we go. For the sake of time, Renzo, what fraction do I write first?
1. Wait, oh, sorry, 12.
Over. Over the leading coefficient, which is 1. Oh, my bad. Okay. Next, you found all the factors of 12. Let's see, 1 times 12, 2 times 6, and 3 times 4. And all that divided by 1. So then all your possible zeros are 1, 2, 3, 4, 6, and 12. Hands if you got it to right there by yourself. Okay, good. From there in blue, I'm going to start with positive 1. Is this in standard form? Let's see, 3, 2, 1, 0. Yes. So then I write 1, 7, 16, 12. Bring down the 1. 1 times 1 is 1. Combine, that's 8. 1 times 8 is 8. Combine, that's 24. 1 times 24 is 24. Combine, that's 36. That's a remainder. This is not my 0. Now I do it again for what, everyone? For negative 1. 1, 7, 16, 12. Bring down the 1. Negative 1 times 1 is negative 1. Combine, that's 7. Negative 1 times 7 is negative 7. Combine, that's that's 9. Negative 1 times 9 is 9 and the negative, so that gives us 3. That's a remainder. That's not our 0. What do I do next, Mr. Well, we're done with 1. Now we're moving on to what? Positive 2. Do it again. 1, 7, 16, 12. 2 times 1 is 2. Combine, that's 9. 2 times 9 is 18. Combine, that's 34. 2 times 34, that's 68. Combine, that's 80. Nope, this is not our 0. So far so good, yeah? Next, I'm going to try now negative 2. Bring down the 1. Negative 2 times 1 is negative 2. Combine, that's 5. Negative 2 times 5 is negative 10. Combine, that's 6. Negative 2 times 6 is negative 12. And guess what? This is our 0. So, how do we write negative 2 without being in synthetic form? X plus 2. What do we have left? Well, if we started with a cubic and we did the division, we lose a degree. So this is x squared plus 5x plus 6. Can we factor this? Yes. What two factors multiply give me 6 when you add them give us 5? 2 and 3. So my factors are x plus 2, x plus 3. Bring down the x plus 2, and all that equal to g of x. And if you got that by yourself? Yeah, some of us. Okay. From 1 to 5, how comfortable are you with this? 4s, 3s, 4s, 5s, okay. And round it goes. That's how it goes. All right, I want to give you one that's a little bit more robust than that. Let's go with this one. Copy this one. Example 1 super duper cube. Function t of x equals 2x cubed plus 11x squared plus 17x plus 6. All right, bless you. Turn to your neighbor, let them know what's the fraction that you're going to write right away. What's the fraction you're going to write right away? Renzo, pass them one. Joseph, fraction. 6 over 2, that is correct. Next, factors of 6. 1 times 6, 2 times 3. Factors of 2, 1 times 2. So, next, here we go. Plus, minus. 1, dividing all this, it gives us 1, 2, 3, and 6. Is that correct? 1 divided by 1 is 1, 2 by 1, 3, 6, and so on. However, what is 1 divided by 2? 1/2. What is 2 divided by 2? 1. What is 3 divided by 2? 3/2. What is 6 divided by 2? 3. So these are all our possibilities. Are we there? All right, here we go. Once again, I'm going to start with positive 1. And my numbers are, let's see, is it in standard form? 3, 2, 1, 0, yes. So I start with 2, 11, 17, and 6. Bring down the 2. Multiply, 2, 13. Multiply 13, 30. Multiply 30, that's 36. That's a remainder, so this is not my 0. Next, we try negative 1. 2, 11, 17, 6. Bring down the 2. That's negative 2. Combine, that's 9. Negative 9. Combine, that's 8. Negative 8. Combine, that's negative 2. This is not my 0. What do we try next, Renzo? Positive 2. Then we got 2, 11, 17, and 6. 2 times 2 is 4, that's 15. 2 times 15 is 30, that's 47. 2 times 47, that's 98. Plus 6, that's 104. That's not my 0. Next, negative 2. So, 2, 11, 17, and 6. That's negative 4, 7. That's negative 14, that's 3. That's negative 6, and guess what? This is my 0. Ooh, how about that, Joseph? All right, so how do we write this, Joseph? X plus 2, yes. And what do we have left? We started with a cubic. That means this is 2x squared plus 7x plus 3. All right, let's see if you did your home plate. Tell your neighbor what to write to factor that trinomial. What goes on top, what goes on the bottom? Elijah, what goes on top? 6, and on the bottom, 7, and so on and so forth, and you know how to factor and do all that, right? All right. So, home plate for tonight. Once again, it's those 4 problems. Make sure you put your practice in. Have a good one, everyone. Enjoy your home plate. See you guys tomorrow. Bye.